Msia from Malaysia.
Thank you, Elizabeth. Bonjour, mesdames et messieurs. Bienvenue à notre présentation du projet, du final du projet. Hello, ladies and gentlemen. Welcome to our final project presentation for Airbus Flyer Ideas 2011. I would like to thank Airbus for giving us this great opportunity participating in this amazing event. This is our first time coming to Paris. It's a beautiful city. Team Malaysia Emas proudly represent University Kuala Lumpur, Malaysia. Malaysia is a beautiful country, peaceful. I hope you will visit us someday. My name is Khairi. I'm currently pursuing bachelor degree in engineering business management. This is my colleague Airul bin Johari, study in engineering product design, and Wan Nurhami in same course with me. We are the third year student and we are pleased to be here. Our mentor is Abu Hanifah and Airbus mentor is Octavio Hernandez Gonzalez. Today is our biggest opportunity to bring the idea forward and show to the world about the undiscovered potential of coupled fiber. During 20 minutes of presentation, we will be covered on these several important areas. For introduction, generally insulation blanket is look like this. It's beautiful actually, but we cannot see it because it's placed behind the cabin interior panel. Basically, its function to create a comfortable environment inside the cabin to protect the passenger from thermal and noise variant. Currently, the material used is made by a series of glass fiber, which is not environmental friendly. So our challenge is we need to find the new material to enable changes in aviation industry. The new material required to be natural, lighter, functional, and obey the safety rule. The idea is to promote the use of biomaterial made from kapur tree. We, Malaysia Emas, believe the idea could be part of Airbus long-term planning towards greener aviation industry. It's also part of our continuous improvement to create a valuable innovation by promoting the use of this humble fibrous material to become a high-end product rather than just be a filler for pillows and mattress. But why did we choose the kapur? So here is the comparison between the kapur fiber and cotton. I just want to highlight some factor, which is kapur fiber is 5 times lighter than cotton. It also has 5 times more buoyant than cork, and it is freely available in our beloved country, Malaysia. So we also have prepared the comparison with the fiberglass. So we want to highlight that kapur fiber is much lighter. It even 8 times lighter than fiberglass. But kapur fiber has having a vital problem of flammability before the treatment. And this is the kapur life cycle. starting from natural to natural. The seed can be processed to produce edible oil for cosmetic and soap manufacturing. The tree is a deciduous type which grown in tropic country. Each tree can produce between 500 and 4,000 pods per season, where each pod contains about 200 seeds. Over there we have the example of kapok pod, and someone will distribute the kapok product, which is in form of pillow, so you can open the zip and touch the fibers. Mature pod will expose the silky smooth fiber used to spread the seed for reproduction. The fiber will dissolve in the soil and as natural fertilizer at end of life. So here is the clearer picture of kapok tree, kapok fiber, seed and natural disperser. You can refer to that. So, potential benefit that we can gain from the idea, we find out there is three. First one, Malaysia almost confident that kapok fiber is capable to be an alternative insulation material for the next generation aircraft. The fiber are simple to produce, which can minimize emission of carbon dioxide and waste during manufacturing process. Installation to aircraft, there is no change required to cabin design. Artificial plant is having a photosynthesis process to live by absorbing carbon dioxide and release oxygen to atmosphere, which by planting more kapok tree for this purpose will enhance the carbon sink. Success of the idea may create demand for the fiber and can create economic spin throughout this product. The team also believes that kapok fiber is capable to satisfy eco-efficiency concept as championed by Airbus. It has the aspect of Kaizen in terms of design, and it has the value for environment. It can create a widened business opportunity, especially to the country which grown kapok. The profit can also be maximized due to low production cost. During production, the energy use will be lower and will reduce the emission of carbon dioxide equivalent. Because it is fully recyclable and biodegradable, it will minimize the waste to environment. This is the business life cycle throughout the kapok product, from design to end of life. By replacing the insulation blanket with bio product is require no change to cabin design. In supply chain, success of this idea will create a farming and plantation in our country, which can create demand and supply between regional supply network. The manufacturing using a simpler and greener technology, which will minimize the carbon greenhouse gas emission. The operation of the kapok, the endurance is well known by our villagers using the pillows for a long time, but we do not have empirical data to prove that in aircraft operation. So in the end of life stage, we can reuse back the fiber by recycle it back to make pillows maybe, and it can go through the biodegradation process. And for the next slide, I will invite my friend.
Thank you, Heidi. Ladies and gentlemen, now we have talked about kapok fiber, so we need to validate this fiber. to ensure it is capable to function as aircraft thermo and acoustic insulator. This material must show to have similar or superior capability of glass fiber. The most important aspect is kapok fiber flammability performance, which is published in Airworthiness Code JAR Part 25. To compliance to this requirement must be shown by the test. Before we start the test, we need to prepare the specimen, which consists of the actual material, glass fiber, taken from decommissioned aircraft. This material is used as a control specimen. The rest is kapok fiber itself. There are two types of kapok fiber, which are treated and untreated kapok. Treated kapok is a fiber that's soaking with the green fire retardant to make it less flammable. As we all know that kapok fiber is naturally high flammable, so we use this solution to make it less flammable. There are three types of tests that we have done, which are thermal, acoustic, and fire testing. For the thermal test, the objective is to measure the thermal insulation blanket with comparing with the glass fiber. For this test, we have improvised the test method. We've used the composite repair kits. As you can see on this slide, this is how we conduct the experiment test to determine the kapok fiber insulation property. As you can see, the specimen is put on the head blanket, and then the thermocouple is installed on the top side to measure the temperature differences. And the next test is acoustic test. In acoustic test, we have measured the noise transmission across the fiber at various thickness and density, as well as comparing with the actual glass fiber. As you can see on this slide, this is how we conduct the acoustic test. As you can see, the speaker and the microphone will receive the noise and record measure on the PC. And the last test we have conducted is fire test. The last test we have done is the fire test. The objective is to compare the flammability capability of the kapok fiber with fiberglass. From this test, this is the sample. That is how we conduct the fire test, and all three tests we had used improvised method. So based on our literature review, the improvised method has shown the reliable result. Okay. As the result for the thermal, as you can see from the table, the fiberglass is capable to insulate 62% of the applied heat, whereas the kapok fiber only capable to insulate in the range of 50% to 60% of the applied heat. And for the acoustic test, in terms of noise insulation, both kapok fiber and the fiberglass have similar capability. And for the fire test, fiberglass shows better capability than kapok fiber. Obviously, the untreated kapok failed completely. However, the treated kapok shows some promising result. It passed the fire test for fire source at 45 degrees. But we Malaysia on Mars believe we do the further research will improvise this test result. So, as a conclusion, we believe that this kapok fibers has a big potential to replace the current material fiberglass because it is purely natural from plants and not harmful to environment. Other than that, it will enhance in terms of commercialization, eco-friendly, and helping the developing countries like Malaysia as a part of Airbus corporate social environmental responsibility. So, to bring our ideas forward, we would like to recommend for the further research about our ideas, which are understanding about the kapok fiber property, and then make a research about the alternative fire retardant solution to improve the test result for the fire test, and then conduct the proper test to comply with the relevant aviation standard. And even now, this material can be used for other applications in the aircraft. For example, as a filo